Okay, this is Mr. Martin. These are the video notes for section 5.2 for Geometry Honors. We're going to be looking at all the different ways to prove that lines are parallel. So um, I'm going to mention this in this section because it's really important. We're going to do two sections back to back. One of them is this section, which is how do we prove lines are parallel? So what conditions are necessary so we can prove lines parallel? When we get to the next section, we're doing something very similar, except in the opposite. We're going to know the lines are parallel, and since the lines are parallel, what can we conclude? So make sure you're very conscious of which way you're going, whether you're trying to prove the lines are parallel or whether you're given the lines are parallel and you're going to make conclusions based on that. So let's go ahead and take a look at all the different theorems and properties that we have today. Um, This one doesn't really have to do with parallel lines, but it says that the measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. So a typical picture that we'll have, we have a triangle, and in order to make an exterior angle, what I need to do is extend one side. So I'm going to just extend that third side. So what I have here, I'm going to call this angle 1. Angle 1 is an exterior angle. Okay, if I extend any side of the triangle, I'll get an exterior angle. I just decided to extend the bottom side, and I get this one exterior angle. So then I'm going to mark this angle with a 2, and this angle with a 3. With respect to angle 1, angle 2, and angle 3 are remote interior angles. Okay, so a little bit of vocabulary here that you need to know what they are. So we've got the exterior angle over here, angle 1, and the remote interior angles. Now, if I put a 4 over here, we've got the angle 4 is an interior adjacent angle. Okay, not so much important for this particular theorem, but something that's important to know. So what this theorem says is that angle 1 is greater than, the measure of angle 1 is greater than the measure of angle 2, and the measure of angle 1 is greater than the measure of angle 3. We're going to eventually get to figure out a more exact relationship between 1, 2, and 3, but for now just know that this angle is greater than either of those two angles. Alright, moving on. So this is our first way to prove that lines are parallel. So if two lines are cut by a transversal such that a pair, any pair, of alternate interior angles are congruent, then the lines are parallel. So we've got two lines. We'll call it M and N. And we're going to cut them with a transversal. We'll call that line S. And then I've got a pair, let's just look at one pair of alternate interior angles. So what we're saying, if angle 1 is congruent to angle 2, then we can conclude that M is parallel to N. Okay, now when we use this in proofs, we can use this shortcut, and I encourage you to learn the shortcuts. You don't have to, you can write out the whole if then if you want. So alternate interior angles congruent implies parallel lines. Alright, if you like that, you can use that. I would encourage you to, but again, if you don't want to, you can write out the whole if then statement. Okay, so that's one way to prove that lines are parallel, if we can get the alternate interior angles congruent. So the next one is very similar. If two lines are cut by a transversal such that a pair of alternate exterior angles are congruent, then the lines are parallel. So let's look at the same picture. We have line M, we have line N, we have our transversal, we'll call it S. So again, let's look at one of the two pair of alternate exterior angles. So again, if angle 1 is congruent to angle 2, then we can conclude that M is parallel to N. So this is our second way to prove that lines are parallel. Again, I would encourage you to use the shortcut here. Okay, alternate exterior angles imply alternate interior angles congruent implies parallel lines. Moving on to the third, if two lines are cut by a transversal such that a pair of corresponding angles are congruent, then the lines are parallel. So same picture, here's line M, here's line N, cut by transversal S. Now keep in mind that our pictures are going to get a little bit more complicated, so you're going to want to refer back to that video in chapter 4, the Intro to Parallel Lines, that references, when you have alternate interior angles, you're looking for an N or a Z. When you have alternate exterior angles, you're looking for what I like to call the flying V's. When you're looking for corresponding angles, you're looking for the F shape. So for this one, I'm going to look at angle 1 here and angle 2 here. This is a pair of corresponding angles. So if angle 1 is congruent to angle 2, then we can conclude that M is parallel to N. Okay, so far we have three ways. So we've got one pair of angles congruent, alternate interior, another pair of angles congruent, alternate exterior, a third pair of angles congruent, corresponding. So any of these three pairs of angles, if they're congruent, then the lines are parallel. Alright, the next two are a little bit different. So if two lines are cut by a transversal such that two interior angles on the same side of the transversal are supplementary, then the lines are parallel. Okay, and then again, here's our shortcut. Interior angles on the same side of transversal supplementary implies parallel lines. So let's draw our little picture. Here's M, here's N, here's our transversal S. So here's a pair of interior angles on the same side of the transversal, 1 and 2. So if angle 1 is supplementary to angle 2, then we can conclude that M is parallel to N. Alright, and then the last way, if you haven't guessed it already, if two lines are cut by a transversal such that two exterior angles on the same side of the transversal, again notice, are supplementary, then the lines are parallel. Here's our short version. Exterior angles on the same side of the transversal supplementary implies parallel lines. Same picture. Here's S, M, N, and then I'll pick this pair, any pair really, if any pair are supplementary. So if angle 1 is supplementary to angle 2, then we can conclude that line M is parallel to line N. Alright, and then we have one more. If two coplanar lines, now we need to specify that the lines are all on the same plane, because it doesn't work if they're not all on the same flat surface. If two coplanar lines are perpendicular to a third, then they are parallel. So for this one, here I've got lines M and N, and here I've got a transversal S. So two coplanar lines are both perpendicular to a third. So if M is perpendicular to S and N is perpendicular to S, then we can conclude that M is parallel to N. So I think there's an example problem in the book that shows the proof of this if you want to see the proof. Basically these are the ways that we have to prove that two lines are parallel. Again, feel free to use the abbreviations. I would encourage you to use them. And then as always, if you have questions about the video or you want some clarification, write down that question and make sure you ask me the next time you see me in class. All right, we'll see you next time.